Okay, so we finished going over how to multiply polynomials and multiply, maybe two binomials together or a binomial and a trinomial and things like that. But there's a couple special patterns that we're going to want to be aware of. Now, they're not going to make too much difference right now with the multiplying, but when we get into some factoring next week, then knowing these special patterns or being aware of them is going to save you a lot of time with some of the factoring. So we're going to kind of introduce them now. So there's a couple special patterns with some polynomials here. And the first one we're going to notice is called the sum and difference pattern. So we know sum means addition and difference means subtraction. So notice we have two parentheses here. Both of them have the same two variables in them. The only difference is that on one parenthesis, one of the binomials, it's an addition sign, and in the other binomial, it's a subtraction sign. So what's going to happen in this situation is if you were to FOIL or distribute like we normally were, a times a would be a squared. Then a times b, and this is a negative b, so b minus ab. Then you would do the second part, which would be b times a, which would be positive ab. And then you would have b times negative b, which is negative b squared. Now, when you go to add these up, you'll notice that you have a positive ab and a negative ab. So those would cancel out, and you would just be left with a squared minus b squared. So the moral to the story here is that when you have the same variables or numbers, and the only difference is the signs are opposite, that middle portion that you normally end up with is just going to cancel itself out. So all you really have to do is multiply the first two terms and the last two terms and put a subtraction sign in the middle. So let's try using this quote shortcut on these problems over here. So for example, if I were to use this pattern on this one, I can see I have x plus 4 and x minus 4. So rather than distributing all four together, all I have to worry about is x times x, which is x squared, and then 4 times negative 4, which is negative 16, and that's it. Because if I had done the other two steps in the distributing or FOILing process, I would have had a positive 4x and a negative 4x, which would have canceled out anyway. So it's a little shortcut you can use when you have one of these patterns. So taking a look at the next one here, 2x times 2x would be 4x squared, and then 1 times negative 1 would just be negative 1. So I didn't have to worry about the 2x times the negative 1 and the 1 times the 2x because those would have canceled out anyway. And then my third one here, 3x times 3x would be 9x squared, and then 2y times 2y would be 4y squared, but of course that's a negative. And again, I didn't have to worry about those middle terms because they would have canceled out anyway, because you would have gotten the same thing twice, just one positive, one negative, which would have added up to 0. Now there's two other patterns, the square of a binomial pattern and also the square. So there's the square of a binomial, and both of the patterns here, there's just an example with a positive sign and an example with a negative sign. So basically what happens is if you have a plus b squared, this is really saying a plus b, a plus b. It's saying you have two of them, or you're taking a plus b and multiplying it by itself. Now you could just write it out twice and then FOIL it out or distribute and get your answer like we normally do. So if you forget this pattern, it's not a big deal. You can just do it that way. But let me show you how the pattern works with an example with actual numbers. So if I have x plus 2 times x plus 2, when you multiply this, right, you would get x squared plus 2x, and then you would get another plus 2x. You're going to get the same thing twice in the middle. Now, in the last example, we would have opposite signs, but here we have the same sign. And then 2 times 2 is 4. Now, what happens is this middle one, whatever you get there, is just doubled. So this is going to equal x squared plus 4x plus 4. So if I wanted to make this into a shortcut, like the last problem, I'm going to take that first term and square it. So here I would have an a squared. At the end, I'm going to have that last term, and that's going to be squared. But then a times b, and that's going to be doubled. So it would be 2ab. So let's see how that would work with the next example. So here I would do 3x squared, which is 9, or 3x times 3x, which is 9x squared. Then at the end, I would have 1 times 1, which is 1. And then 3x times 1 is 3x, but then if I double it, I would get 6x. So it's a little bit of a shortcut, not as much as the other type of pattern, but it could be used. If you'd rather just write it twice and distribute your FOIL, by all means, you may do that. And then the third example here, 2x times 2x would be 4x squared. 4y times 4y would be 16y squared. And then if I multiply those two together, I would get 8xy. And then if I double it, it's 16xy. All right, so let's take a look at the other one here. Now this one is a minus b. So this is really like a minus b times a minus b. So the only thing that changes here is that this addition sign will become a subtraction sign. So this would be a squared minus 2ab plus b squared. The last term would still be positive because a negative times negative will make that a positive. All right, so let's try using this shortcut for a couple. So here, x squared, or x times x. In the middle, I got to multiply these together. So x times negative 3 is negative 3x. I'm going to double it to get negative 6x. And then negative 3 times negative 3 would be positive 9. Okay, then the next one, 5x times 5x is 25x squared. 5 times negative 2 is negative 10x, and I'm going to double it to get negative 20x. And then negative 2 times itself is positive 4. And then the last example here, 4x times 4x would be 16x squared. 4x times negative 1 is negative 4x, and I would double it to get negative 8x. And negative 1 times negative 1 is positive 1. So again, you can use these shortcuts or patterns to kind of get you the answer a little bit quicker, but you can certainly just do your FOIL or distributing like you've done before. So to review, if we take a look at this one, notice the signs are different. So this is where I'm just going to take the first term and square it, and the last number and square it, or multiply it by itself, and put a minus sign in the middle. It's always got to be a negative because 3 times negative 3 is negative 9. Okay, so same thing here. 4x times 4x, 16x squared. Negative 2 times positive 2 is negative 4. 5x times 5x, 25x squared. Negative 1 times positive 1 is negative 1. Here, again, there's opposite signs, so all I have to do is the first and the last. 3x times 3x is 9x squared. Negative 2y times positive 2y is negative 4y squared. X times x is x squared. Negative y times positive y is negative y squared. X times x is x squared. And negative 1/2 times positive 1/2 is negative, and that would actually be 1/4. All right, so on the back, we're going to practice the shortcut with those other patterns. So here, this one is a plus sign, but I have 2 of them. So basically what I'm going to do here is I'm going to do x times x, and I'm going to get x squared. 3 times 3, positive 9, and then I have to do x times 3, which is 3x, and double it, and I get positive 6x. On the next example, 4x times 4x, 16x squared. Negative 2 times negative 2 is positive 4. And to get the middle number, 4x times negative 2 is negative 8x, but I'm going to double it and get negative 16x. Number 3, 5x times 5x, 25x squared. Negative 1 times negative 1 is positive 1. And to get the middle, I'm going to multiply those together. 5x times negative 1, which is negative 5x. And then I'm going to double that, negative 10x. Number 4, 3x times 3x is 9x squared. Negative 2y times negative 2y is positive 4y squared. And to get the middle number, I'm going to multiply these two together, getting negative 6xy, but I have to double it, so I'm going to get negative 12xy. X times x is x squared. Y times y is y squared. When I multiply them together, I get xy, and I need to double it, getting plus 2xy. Last one here, x times x is x squared. 1/2 times 1/2 is actually 1/4. To get the middle number, I'm going to multiply these together. It's 1/2 x, but I have to double that or multiply it by 2, which actually just gets me 1x. So if we think about this, we could easily find the missing term. So here, notice these two are opposite signs. So that means it's just x squared minus y squared. In this example, this is one of the ones where we have x plus y twice. So we will have a middle term. We just have to multiply the x and the y together, which is xy, and double it. So 2xy. Again, opposite signs, the middle cancels. A squared minus 4b squared. Over here, it's a minus 2b, and we're having that twice, so two negatives. We're going to multiply these two to get that middle number, so it's negative 2ab, and we have to double it to get the negative 4ab. The last term will just be negative 2b times negative 2b, which is plus 4b squared. Okay, opposite signs, 2w times 2w is 4w squared, and 7 times 7, that's where they got the 49. Okay, this one here, 3x times 3x would be 9x squared, and then they already have the 6x doubled and the 2 squared. Okay, last couple practice ones. Remember, opposite signs, t times t is t squared. 7 times negative 7 is negative 49. That's all we have to do because they were the same with opposite signs. Sum or difference of two squares. Here, opposite signs again, 7x times 7x, 49x squared, 5 times negative 5, negative 25. Opposite signs here with everything else the same, x times x is x squared, negative 4y and positive 4y is negative 16y squared. Okay, 4, 5, and 6 are the other pattern. This is the one where we do have a middle. It's just going to be the multiplying those and then doubling it. So first we have m squared, then negative 9 times negative 9 is positive 81. But we have a middle term here, which is negative 9m doubled, which would be negative 18m. 3y times 3y, 9y squared. Negative 4 times negative 4, positive 16. Multiply those together, you get negative 12y, double it, negative 24y. Last one, 4n times 4n is 16n squared. 5 times 5 is 25. Multiply them together, you get 20n, double it, 40n. Okay, so once again, you do not have to use these patterns in order to multiply these binomials together, but they will help you save some time if you are good at remembering them. Otherwise, just do your FOILing or distributing like you would normally.